I'm going to show you another way besides using y equals mx plus b to find the equation of a line. Now, if you know how to use y equals mx plus b and you know how to use it well, and then you're able to get ax plus by equals c form from that, you don't need any of this. I'm going to show it to you because maybe you take another math course down the road and they start falling back on this. I want you to be aware of it and maybe try it a little. Also, if you use the directions in Connect Math, they rely on this some. So it's good to have an awareness, but you can get all the way through my test and get 100 using y equals mx plus b. My sister teaches math in another part of Connecticut, and she and I had a discussion years ago. Do you prefer using slope-intercept or point-slope? She likes point-slope. I like slope-intercept. I just know that y equals mx plus b, knowing the slope and the intercept are good. She said, yeah, but the other one, you know, they just don't have to deal with fractions as much. They cross-multiply and stuff like that. So it's tempting, but we're going to do point-slope. Here's what point-slope has for you. Instead of having y equals mx plus b, they're going to use the same three letters in the same order to get the job done, right? There's your exact y, there's your slope, there's your exact x. But they have parentheses in there, and the formula that you'd have to learn instead of y equals mx plus b or y equals slope x plus intercept is y minus exact y equals slope times the quantity x minus exact x close parentheses. So you got to know the parentheses, but it gets the same job done because it's based on the same relationship. So they're going to do the same thing as we do in the first step. Fill in y sub 1, m, and x sub 1. And then you distribute. That's what they have to do because they have parentheses, and the first thing you have to do, get rid of the multiplication. Our multiplication was to multiply m times x sub 1. That was our need to multiply. Their multiplication happens twice. They have to distribute. Then the parentheses are gone. Then they isolate either. If they want to get y equals mx plus b, they go through the process of isolating y. If they want to get the job done where they have ax plus by equals c, they have to isolate c. So what I'm going to do with theirs is I'm going to get it to the point where we do the distributing, and then I'm going to say I could isolate y by doing this, and you get the exact same answer we got earlier when we did y equals mx plus b, or I'll show you how to get that so that they isolate the constant c. But no matter what, if you're going for this one, you have to memorize another formula, know how to use it perfectly, and therefore you have to memorize twice as much about lines. That's probably a big reason that I don't like to say, let's do this as well. It's a better way, it's a different way. Now you got options. You can stay with y equals mx plus b. A lot of my students in the past have done that. Well, here they are. We're going to look at three lines that we want to do. We're going to say, find the equation of the line through this point with the given slope, or the known slope, right? And colon. And the first one that we have is they want me to go through the point negative 2, 5 with a slope of negative 4. Through negative 2, 5 with a slope of 4. So we got to do their thing, right? We got to do that same kind of thing. We got to find the exact y to be 5. We got to know the slope is 4. And we got to know the exact x here is negative 2. Now, if you memorize their formula, you're looking at it over there. This is the same every time, y minus. Then comes their exact value of y. Then the equal sign. Then we have our slope, which for us here is 4. And then we definitely have parentheses and the letter x, minus. And then we need our exact y, which is actually negative 2. All right, well, I never put you through a double negative the way I had you doing it, but okay. Done perfectly, y minus 5 equals 4 times x plus the opposite of negative 2, so that's plus 2. Before we distribute, we had to do that. So now we're going to get y minus 5 equals 4 times x plus 4 times 2, which will get you 8. And now if you want to get the equation of this line the way that they would to get c alone, you would have to add to both sides. You would have to get it so that your number is on one side and your x on the other. I mean, if we wanted to do y equals mx plus b from here, we would go ahead and option 1 is to add 5 to both sides. You get y equals 4x plus 13. Okay. Now the other thing they had was this y minus 5 equals 4x plus 8, and we might want to get the number isolated with x coming first. And we could subtract 4x off both sides so that the x comes over here and add 5 to both sides and all that, and we're going to get into some negatives. But I like the x's where they are, so I'm going to take this 1y and I'm going to subtract 1y, and I'm going to just do that on both sides. So this is gone. Now I got my numbers to be over here, and I'm going to subtract 8. Okay, and now if we go ahead and cancel this out, we're going to get negative 13, 5 plus 8, and then strong on the negative, 13. Said it right. Now I'm fixing the writing. There you go. Negative 13 equals, and you got 4x plus negative y. And that's the same thing because you got your x. If your x comes first with a positive coordinate and negative positive coefficient, y is looking like that, we get the job done. It's able to take you through either one of those two and get you either y equals mx plus b, where the slope is 4, or ax plus by equals negative 13. And the point, negative 2, 5 should work. If I put a negative 2 in there, I get negative 8 plus 13, I hit a 5. If I put a negative 2 in there for x, I get negative 8 minus 5 more, I hit negative 13. Both work great. So that's how it works, and it's not too bad because you got to distribute, and you had a double negative. So I'm not going to say there was never a double negative. I got another couple of these to do for you. So we're going to change up for this second one. Remember, if you said, hey, you went too fast, just back up the video. We're going to try this one. Through the point 2,7 with a slope of 3 over 2. Okay. So we need a y. Exact y is 7. We need the slope. Slope is given as 3 over 2. And we need an exact x. In this case, x is 2. So when we go y equals mx plus b, we would get to our work, but I want to go their way, right? They want me to start with y, the letter y, minus, and then they want an equals, and they want space before I have my x minus, because that's what their form looks like. And now I have to drop the 3 items that I have into their locations. Here's where my y goes, m. It's the same 3 in the same order as y equals mx plus b, and x. So the y minus 7 is going to hang out for this step. But this is going to be 3 over 2 times x, which is 3 halves x. I'll go plus negative. I got 3 over 2 times 2. I got the negative already there, so 3 over 2 times 2 gets me 6 over 2 for 3. Now I have option 1. Option 1 is to get y alone, so I'll add 7 to both sides. And in order to do that, I get y equals the 3 halves x that didn't change. And I go with negative 3 plus 7, that's opposites. Subtract to get 7, strong on the positive, so 7 minus 3 is going to get me to the 4. And this is where my x is. So if I put in my 2, I will get 6 over 2. It's going to get me 3 plus 4 hits the 7, so that works. Now I have this other way that they had it. They were sitting on y minus 7 equals 3 halves x minus 3. And now we want to get it so that we can get no fractions, and then we want to isolate the number. So we're going to take this thing as it stands, and we have a bunch of things here. We have 1 over 1 space y plus negative 7 over 1 space equals 3 over 2 space x plus negative 3 over 1 with space behind it. The only fraction I have here is a 2, so the LCD equals 2 over 1. So I'm going to multiply each one of these by 2 over 1. And we'll go see what we've got. The only place that it cancels is this black 2 canceling with that blue 2. Otherwise, we get 2y plus negative 7 times 2, negative 14 equals, those 2's have canceled. I got 3 times 1 with an x, 3x. Plus, I got negative 3 times 2 for negative 6. My goal is to get the numbers alone I like my positive x. So I'm going to subtract 2y off each side. And that means this is my number side, so this has to go plus 6 plus 6. I got negative 8 equals 3x plus negative 2y. It looks like everything doubled. Instead of y, they got 2y. Instead of 3 over 2, they got plain old 3. Instead of 4, they got 8. But this is when I write the x first, plus negative 2y equals negative 8. We're going to go ahead and we're going to plug in 2 for x and 7 for y. 2 for x gets me 6. 7 for y gets me minus 14 or negative 14. 6 minus 14, subtract, get an 8. Strong on the negative, it hits. It works for both. So if you want to learn this extra formula, it is doing the same job as y equals mx plus b, and will get you to the same kind of results. How about when those fractions stick around? So I am sneaking in some fraction work here. I do want you to work with the fractions either on your calculator or continuing to try to improve your skill with fractions. But one way or another, they need to be dealt with. There's no guarantee fractions will never work their way into our problems. So I'm going to try this point through. And I'm going to change this up. The point slope form, we need the slope and we need a point. Let's find the equation of a line through. Because it's a form of this same type of thing, these 2 points. And the points here will be 3, 1, and 6, 7. We've done this exact problem before, and that's the purpose of it, is so you can see the process, how much is different and how much is the same. So we have 3, 1, and we have 6, 7. 1 plus 6 gets me 7, 3 plus 3 gets me 6. M equals 6 over 3, both positive. M is 2 over 1 for 2. So I have my slope as 2. Last time I went with the 3, 1. This time I'll go, it's the same points. It should get the exact same outcome. I'm going to go with 6, 7. So here, the y value is equal to 7, and the x value is equal to 6. And I want to do what they have us learning, which is y minus some value equals slope times parentheses x minus some value and close the parentheses. Y equals mx plus b, so I need y, then m, then x. My y value is 7. My m value is 2. I guess I didn't have the fractions. 6 over 3 worked out to a whole number. We lucked out. X is 6. But you can still see how this, now it doesn't have fractions, and I could give you the same problems with fractions and the fraction difficulty would exist. So this is not like, oh, why don't I use that? It never has fractions. I was really focusing here on the change in process and hammering you with the fractions in the earlier ones. So this is not an easier process, it's more memorization, but if you do find the process easier even with fractions, feel free to go with it. This is y minus 7 hanging out, and then we get 2 times x plus 2 times negative 6, negative 12. So option 1 is to isolate y. And in that case, I would do an addition of 7 to each, and this will be gone, and I'll see that y is all I've got there in 2x, negative 12 plus 7. Subtract for a 5, strong on the negative, and you're going to get that. The other option they had was from y minus 7 equals 2x plus negative 12 was to isolate your value for the constant. Now, you want to have your leading term be positive. You have the option of subtracting y from both sides and adding 12 to both sides, and you certainly could do that. I want to show you what some other teachers would possibly have you do, though. They'll say, oh, get the number on the right, get the variables on the left. So, okay, the y is where it belongs. I'm going to have to subtract 2x and bring that out here to create that scratch out. And this 7 can't stay here, so that's plus 7 and plus 7, and that's gone. So now I have negative 2x plus 1y equals, and then subtracting there, negative 12 plus 7 is going to get me negative 5. But with ax plus by equals c, we try not to have that lead off negative. And we have that option. What we can do is divide every one of them by negative 1 so that we get what we want for our leading term. We can only control so much, but we can control that much. This gets me a positive 2x plus a negative 1y equals positive 5. and that would work as well. But as I said, if you wanted to leave the x's, bring the y's over there, bring the 12 over, by doing the inverse operations, you would get the same thing. And now what happens is 3, 1 should work in there. We know 6, 7 got us here. Let's see if 3, 1 works. 3 in there. 2 times 3 is 6. 6 minus 5 is 1. That's what we expected. How about 3 here? 6 there. 7 there. So let's see. We got, 6, 7. Yeah, 6, 7. So if we go with 6 times 2 is 12. 12 minus 7 does equal 5. They both work. So this is another option. It's not something you need to do, but I want you aware of the possibility of learning an extra formula so that you can do something in a different way, but not a requirement to get through this course. That's it.
Brilliant.